Hello pre-calc honor students, our last lesson of the semester, solving more difficult trig equations. We're going to use identities and technology to solve more difficult trig equations. So here's our first example. Solve 2 sine squared theta minus 1 equals 0 for theta between 0 and 360 degrees. Well, let's take a look here. We can first try and isolate the sine squared by saying 2 sine squared of theta equals 1. And so then the sine squared of theta equals a half. Now when you take the square root of both sides, don't forget, you're going to get the absolute value of the sine of theta equals 1 over the square root of 2, or sine theta equals plus or minus 1 over the square root of 2. And now we can use a couple of unit circles to decide where we're getting our answers here. Theta. When is the sine of theta equal to 1 over the square root of 2? Well, that's when you get that 0.707, which is about here, and you get that at the 45-degree angles. You're also going to get it in this quadrant too. So from this solution, we get 45 degrees and 135 degrees. Now consider also, though, when the sine of theta equals negative 1 over the square root of 2. That's down here at 225 degrees and 315 degrees. And sure enough, there's our 4 solutions. Now compare these two problems. X squared minus 3x minus 4 equals 0. Oh, well I can do that. Just factor x minus 4 times x plus 1 equals 0, x equals 4, or x equals negative 1. I'm done. It's a quadratic, 2 answers. Cool. But compare with this, which looks also like something in quadratic form, where if we let u equal cosine theta, we get u squared minus 3u minus 4 equals 0. And it's a similar approach. U minus 4 times u plus 1 equals 0. So u equals 4, or u equals negative 1. But don't stop there, because you're supposed to solve for theta. And remember, u equals cosine theta. So the cosine theta equals 4, which can't happen. No solution there, because there's no way to get an x-coordinate of 4 on the unit circle. Or the cosine theta equals negative 1. And that can happen on the unit circle. That's back here. At negative 1 comma 0, where theta equals 180 degrees. Now technically plus 360 degrees times n, and we get an infinite solution set. If I limit it to 0 to 360 like I do in most problems, then we just get one answer. So you can see how just because it's in quadratic form doesn't mean you're going to get 2 answers. That was true when we had a polynomial equation, but this is a trig equation now. Now solve sine squared x minus sine x equals cosine squared x from 0 to 2 pi. Well, when you've got more than one trig function, it helps to get it all just in terms of one trig function. So let's replace the cosine squared of x with 1 minus sine squared of x. So that gives you 2 sine squared x minus the sine of x minus 1 equals 0. And we can look at this in quadratic form again and try and factor it. 2 sine x times the sine of x, that'll give us the 2 sine squared x. And 1's here, and we want to get a minus there, so we're going to go minus 1 times 2 sine x, and plus 1 times sine x will give us the minus 1 sine x. So as we factor that, we get sine of x equals negative a half, or sine of x equals 1. And we look at some unit circles on both of these. When is the sine negative a half? That happens at negative pi over 6, or let's view it as 7 pi over 6, 11 pi over 6, since we're restricted to 0 to 2 pi. When does the sine equal 1? That's straight up here at pi over 2. And that should mesh with our answers from the book. 7 pi over 6, pi over 2, and 11 pi over 6. Actually, I should put the pi over 2 here first. You should list them in ascending order. Pi over 2, 7 pi over 6, 11 pi over 6. Now example 3. Sine x tan x equals 3 sine x for 0 less than or less than 2 pi. So be careful. Don't divide both sides by sine. When you do that, you get tan x equals 3. No. You missed out on answers. Don't do that. Instead, factor out the tangent of the sine by subtracting 3 sine x from both sides. Factor out the sine, tan x minus 3. And so we get the sine of x equals 0, or tan of x equals 3. So from this one, I can use my unit circle. When does the sine equal 0? That's 0 and pi. When does the tan x equal 3? Well, we're going to get two possibilities when you have a slope of 3. Now that's not a special value for the tangent, so I'm going to go ahead and use inverse tangent of 3 and get something in radians, because it's just going to be a calculated answer in radians. And we get x equals 1.25, so that's 1.25, but now the other answer for tangent is going to be pi away from that, so we can get a second answer of 1.2 plus pi, getting up to about roughly 4.39. So there are three answers, 0 and pi, which we got exactly over here, but then these we had to calculate, 1.25 and 4.39. So 4 answers on that one. Now example 3. And we just did example 3. Here were the answers. Here's example 4. Solve from 0 to 360. 2 sine theta equals cosine theta. Well, the trick here is to actually realize that there's no squaring, so it's very hard to convert. But there is a nice way to convert this into one trig function by dividing both sides by cosine theta. And I might say, oh, don't divide by anything containing the unknown, you might lose roots. Well, we don't have to worry about cosine theta equaling 0. That only happens at cosine pi over 2, and pi over 2 does not work. Cosine of pi over 2 is 0, sine of pi over 2 is 1, 2 does not equal 0. So we're all set here, because we can change it to 2 tan theta equals 1, so tan theta equals a half. Now that's not a special value for the tangent, but we can look to see where we're going to get our answers. A slope of roughly a half is something like this, and we're going to get a first quadrant answer and a fourth quadrant answer, or third quadrant answer. And one comes off the calculator as the inverse tangent of a half. And that works out to be 26.6 degrees. Then we can get our second answer by taking 26.6 degrees and adding on 180. The tangent answers are all 180 degrees apart from each other. And there's your 206.6 degrees. And that checks out with the answers in the back. Now example 5, the trickiest example yet, 2 sine theta equals cosine theta plus 1. We can't do our little trick we just did, divide both sides by cosine. We'd introduce a secant over here, and that's going to be too messy. So there's two methods. First method is basically to start trying to get this sine into cosine form. And one handy trick on this is just to replace the sine of theta with plus or minus the square root of 1 minus cosine squared theta. Just to get it all in terms of one trig function. Now the plus or minus is obnoxious. 1 minus cosine squared theta equals cosine theta plus 1. And what we can do, I think you see it coming, like we did with the radical expressions before, square both sides. Now you could have also just squared both sides right away and replaced sine squared with 1 minus cosine squared, and some people find that a little cleaner. So we get 4, and the plus or minus squared disappears. 1 minus cosine squared theta equals cosine squared theta plus 2 cosine theta plus 1. Okay? So that's 4 minus 4 cosine squared theta equals cosine squared theta plus 2 cosine theta plus 1. So let's get everything on one side. 5 cosine squared theta plus 2 cosine theta minus 3 equals 0. We're lucky that this factors 5 cosine theta and cosine theta. And yeah, let's go 3 and 1. And we want to make it a plus 5 cosine and minus 3. So we get cosine theta equals 3/5, or cosine theta equals -1. Now this one we can do with unit circle. When does the cosine equal -1? When do you get an x squared -1 back here at 180 degrees? So here's one of our answers. This answer we'll have to calculate. 3/5 is about 0.6. We get this answer. We're also getting an answer down here. Now the calculator will tell you one answer. Let's call that theta 1. Inverse cosine of 3/5. And from that you get 53.1 degrees. To get our other answer, if this is 53.1 degrees, then the other answer is going to be basically negative 51.3 degrees. And to get it in the 0 to 360 range, let's come up with a coterminal angle by adding 360, and we get 306.9 degrees. And there we go. There's our exact answer at 180, and there's our two calculated answers at 53.1 and 306.9. Now, since we squared both sides, we may have some extraneous roots. And this is what you have to watch out for. You can actually go back and plug these in, and you'll see that 306.9 does not work. It works maybe way back in the equation where we squared both sides, but it doesn't work in the original equation. And you can actually visually see that why that's true when we look at method 2, which is actually to graph both trig functions and see where they cross. And from 0 to 360, they only cross in two spots, the 180 and right here at A, which is at 53.1 degrees. They do not cross at 306. At 306, they're exact opposites of each other, and when you square those, you would get the same number. Okay? But that's why that extraneous root is eliminated. I also came up with a way to do degrees on GeoGebra just by stretching out this axis and then doing an f function first that converts the degrees into radians essentially, and then I do all my trig functions based on, instead of 2 sine x, 2 sine of this converted, because the x is acting like it's in degrees. So that was my trick for coming up with a degree table. So this is degrees. I believe that is it. Flange out.